Now, this isn't your average system. In fact, this is a system of dwarf planets. I mean, hold on, let me explain before you click away. Now, are you sure? Are you sure that you know what a planet is? Because the definition is actually a little fuzzy. According to NASA, a planet must orbit the Sun. Must be round because of its own gravity and has to have cleared the neighborhood around its orbit. That last part is kind of ambiguous because no one wants to send a bunch of humans out chasing down all the little rocks in our solar system. So the definition of cleared the neighborhood is kind of up to astronomers. And that's where things get interesting. Pluto was reclassified as a dwarf planet in 2006 because we found out that it hadn't cleared the neighborhood around its orbit. But that does leave the question open, how do you define clear? The Kuiper belt, which is where Pluto lives, is filled with hundreds of smaller icy bodies, and Pluto hasn't cleared any of that out. So by our current definition, Pluto's not a planet. But the line is blurry. Take Eris, for example, another dwarf planet located in the scattered disk beyond Neptune. Eris is almost exactly the same size as Pluto and orbits the Sun in a very elongated path that takes it closer to the Sun than Pluto ever gets. But Eris shares its orbit with Neptune. So by my definition, it might be a planet. Is it fair to say that a planet doesn't need to completely clear its orbit, but it does need to have enough gravitational pull to clear a lane occasionally? Like maybe once every 10,000 years or so? Well, here's a new system which will either expand our definition of planet or make us stick to our guns. There's a single star named Kappa, which is about half the mass of our Sun and is about 130 light-years away. Kappa is accompanied by 3 planets roughly the size of Earth and 1 planet about the size of Neptune. And all 4 of these planets are locked in a strange three-way dance. The smallest Earth-sized planet orbits the star at a distance of 8 million kilometers and takes 17 days to complete an orbit. That's about twice as fast as Mercury. The second Earth-sized planet is slightly larger and orbits Kappa at a distance of 19 million kilometers in 26 days. And the third Earth-sized planet is nearly 40% bigger and orbits Kappa at 31 million kilometers in 41 days. So the 3 inner planets get progressively larger and their orbital periods get progressively longer. But wait, there's more. Orbiting the largest of these 3 planets is a 4th body, which researchers think is somewhere between an exomoon and a planet about 2 times the mass of our moon. And this rocky body only takes about 6 days to circle the 3rd planet. So obviously this system is a little wacky, but it also seems stable. If the innermost planet were even a little more massive, it would have pulled the 2nd planet into its orbit long ago. Likewise, the outer planet would have taken the 3rd planet if it were any less massive. So the masses of all 4 bodies are finely balanced to create this unusual system. And it's hard to imagine how such a system could evolve. All 4 bodies had to form separately and then come together at just the right configuration. Or maybe they all formed together in just the right configuration. But that seems pretty unlikely. We don't really know how such a system would even begin to form. And that's why it could teach us a lot about planetary formation. For starters, the fact that we have 3 bodies that are very similar in mass orbiting a low-mass star could tell us how planetary systems evolve. Some models suggest that these small bodies are actually failed stars. They're not large enough to sustain nuclear fusion, so they never became true stars, but they did gather up enough material to become planets. Other models suggest that they are in fact captured asteroids and comets. And the strange arrangement of the orbits could be explained if the system experienced a violent disruption in the past. Maybe something from the neighborhood nudged the planets out of their nice evenly spaced orbits. But whatever the mechanism, we know that we have a stable system. It's stable now, but that doesn't mean that it always will be. Gravity is a very complicated business. Remember that every body in the system has an equal gravitational pull on every other body, and over billions of years, those tugs add up. And eventually, the configuration of the planets could change in a dramatic way. Some of the planets could collide and merge to create fewer larger planets. Others could get thrown out of the system altogether. Kappa could lose some of its planets, but it could also gain some. If something came crashing into the system from the outside, Kappa could end up with more planets than it started with. And we've seen some evidence of this happening to other stars in our galaxy, and that's when things get a little weird. Astronomers believe that Kappa's fourth planet, the one that's orbiting the third planet, was captured from elsewhere in the system. It doesn't resemble the other planets. It's bigger, more massive, and made of rock instead of gas. It's a lot like the Moon, and the fact that it's relatively large tells us that it was captured early in the solar system's history. Otherwise, it would have been destroyed by tidal forces. But where did it come from? Researchers believe it was originally a free-floating planet, something like a rogue planet, wandering through the galaxy on its own, just like many known rogue planets. But there's a difference. Rogue planets can't have any moons. Moons require the gravitational influence of a planet to keep them in place. So, if this fourth body had a moon, it wouldn't be a rogue planet, it would be a dwarf planet. And that's where things get a little crazy. Imagine the fourth planet wanders into the system and starts orbiting the third planet. Now it has a planet-sized body orbiting it. According to our current definition, that makes the fourth planet a moon and the third planet a dwarf planet. In fact, there's nothing preventing the second planet from also capturing a wandering body and forming a moon of its own. If that happens, we would have two dwarf planets in this system. Kappa would be surrounded by 5 bodies that aren't quite planets, but they aren't quite moons either. It would be a full-on system of dwarf planets. Now, this scenario is speculation on my part. It's based on our current understanding of the solar system, but we don't really know how planetary systems work. There's still a lot we don't understand about how these systems form, how the bodies interact, and whether they stay stable over long periods of time. There's a lot of work to be done, but if you ask me, it's worth it. The more we learn about planetary systems, the more we learn about our own origins. And the more we learn about our origins, the better we understand our place in the universe. We are stardust, after all. Every atom in our body was forged in the heart of a star. We are literally made of star stuff. And while it may seem odd to think about worlds covered in ice and darkness and worlds without a star at all, those are just 2 examples of the places that our own star stuff may exist. When we look up at the night sky, we see a beautiful collection of lights, but each of those points of light is hiding countless worlds. Worlds that may not seem very hospitable to us, but could be perfect for other forms of life. Worlds that are frozen solid, worlds that are scorching hot, and worlds without a sun at all. Earth is amazing. It's got the perfect mix of ingredients for life as we know it, but that doesn't mean that we're the norm. It's possible that our galaxy is teeming with different kinds of life, much of it unlike anything we can imagine. For life to conquer the universe first, it has to get going. When we look at life on Earth, it's possible that it all has a common ancestor. Life started at one spot and branched out and became all the different kinds of life that we see. But how did it start? The first question to answer is, what is life made of? Top of the list are the most basic building blocks, chemical elements. Here's what I know about the universe. The laws of physics appear to be the same everywhere. The chemical composition, the elements are the same everywhere. And the cosmos creates these elements not from the Big Bang but from stars. Over the course of a star's life, it creates elements. And when a star dies, these elements are blasted out into space in a supernova, spreading the ingredients for life out into the cosmos. We, the Earth, our solar system, all the ingredients that make us were forged in nuclear fires. So the death of stars leads to the birth of music, life. Those key ingredients include oxygen, nitrogen, sulfur, and phosphorus. But the element most central to life as we know it is carbon. All life as we know it on Earth is based on carbon. Carbon forms the structure, the architecture of our living molecules. Carbon is an incredibly versatile building material. It can bond with other elements to form long-chain molecules, each with different properties. As an element, it seems to be capable of producing a vast and complex chemistry. And that complex chemistry is what we find in life. We call this organic chemistry. But getting from basic organic molecules to complex life forms is a big leap. We don't really have the slightest idea, to be honest, about how life on Earth got started. A really big question is how you go from a mix of relatively simple organic molecules to a living system. We know it all starts with basic elements created in massive quantities by the death of stars. But how do you start connecting those Lego bricks together to build that first cell? The short answer is we don't know, but we have some ideas. Chains of organic molecules become more and more complex. Amino acids form proteins, fatty acids form phospholipids, which make cell membranes, nucleic acids form DNA, the molecule that stores genetic information. Eventually, a simple cell emerges. All of the bits you need to plug together to build a cell from scratch. It all seems to exist out there in outer space. We found organic compounds everywhere. They're all over the place. Planets, comets, gas clouds, the very basic ingredients of life, available elsewhere in our solar system, so there could be life everywhere. In 2018, NASA announces it's found organic molecules on another planet, a planet we've always suspected of harboring alien life, Mars. So whenever NASA has a press conference and they say they have some important results to report on about Mars, everyone goes nuts. The internet goes mad. Maybe we've got photographed evidence of little green men in a UFO. This time it's the Martians. They're going to tell us they found the Martian. The world listens 'cause everyone wants to know. Everyone asks the question, have we found evidence of life? For 6 years, the Mars Curiosity rover has been exploring a region called Gale Crater hunting for signs of ancient life. A bit like fossil hunting on Earth, Gale Crater is not unlike places on Earth that can preserve fossils. So, a really good example of this would be the petrified forest in Arizona. This looks like a piece of wood, but in fact it is stone. It is all stone, but it used to be a tree. This fossil lived 200 million years ago. This patch of desert in Arizona once looked completely different. This landscape looks very dry right now, but 200 million years ago, it was wet swampland with trees and flowing water, like the petrified forest. Mars has also changed over time. Gale Crater was once a lake bed filled with fresh water. And it was just so exciting because we knew then that we had landed right on top of an environment that once had tons of flowing water and could very well have preserved organic materials even though it looks very barren and desolate to our eyes. In 2018, Curiosity drills into this ancient Martian lake and discovers organic molecules. Finding organics on Mars is so exciting just because, wow, those are the building blocks of life. Not just the elements, but actual molecules. There was a wave of excitement after the announcement of organics found on Mars and complex organics. It's not totally indicative that life is there, but it's a really good telltale sign that there may be possibly life forms on Mars. The results aren't proof of Martians, but the ancient lake bed is evidence that the red planet once had something else crucial for life, liquid water. It's one thing if you have all these ingredients lying around for life. You could have, carbon over here and hydrogen over here, maybe methane or whatever, but you have to mix them together. Life needs a liquid to mix essential chemicals together. We're used to thinking of Earth as the only water world in our solar system. But new evidence says otherwise as extraterrestrial visitors carrying liquid water from outer space reveal. In 2017, astronomers tried to solve a decades-old cosmic mystery by analyzing a strange object hurtling through our solar system. It was a comet named Haumea. It was the first comet ever to visit our solar system from interstellar space. It was like a delivery from somewhere else. As it flew past Earth, scientists pointed every telescope they could find at it, and what they saw amazed them. This visitor from afar didn't look like any comet they'd seen before. It was oddly shaped. It seemed to accelerate as it approached the sun. And, in a flash of inspiration, some astronomers suggested that it might not be a comet at all, but something much more exotic, a huge alien spacecraft. Comets are chunks of ice and dust leftovers from the formation of the planets. They smell of organic molecules. Scientists believe that early Earth was bombarded by comets. These icy interlopers delivered the building blocks of life, including some of the key ingredients for life as we know it, amino acids. One theory suggests that life on Earth began when these amino acids fell to our young planet in a rain of organic molecules from space. Now, if it happened here, it could happen elsewhere. If life arose separately on another planet, it could arise again if conditions were right. But conditions need to be really right. Let me show you. This is Europa, one of Jupiter's moons. It is the most likely candidate for life in our solar system. Europa is the least massive of the four big moons of Jupiter. But what makes it so special is the fact that it is surrounded by radiation from its big brother, Jupiter. That radiation blasts the surface of Europa, blasting out the oxygen from its cracked ice crust, leaving behind molecular oxygen, the stuff we breathe. And the broken ice forms a slushy ocean beneath the surface. That's a lot of water. It's estimated that there are twice as many gallons of water on Europa as all the water on Earth. And water isn't the only thing that's similar to Earth. It also has a rocky mantle and core, making it a candidate for having magnetic fields, a protective shield against lethal radiation. Plus, it could have a liquid ocean and an atmosphere. Does it have life? Well, we don't know yet, but we think it might have what it takes. Underneath its frozen crust, researchers think there could be a liquid ocean containing 2.5 times the amount of water than all of Earth's oceans combined. That's a lot of water. The Moon has been in Jupiter's gravitational pull for billions of years, making it one of the most geothermally active bodies in the solar system. Scientists think that tidal flexing caused by Jupiter's gravity could heat up the ocean, possibly creating hydrothermal activity similar to Earth's deep sea vents. Hydrothermal activity is a great source of energy. And energy equals life? You're looking at Titan, Saturn's largest moon, and a place so bizarre that it's almost alien-like. This is the only moon in the solar system that has a dense atmosphere. It's the only body in the solar system besides Earth that has stable bodies of liquid on its surface, but it's not water that Titan is famous for. Its lakes and rivers are made of hydrocarbons like methane and ethane, which makes it very inhospitable to life as we know it. But life as we don't know it could survive there. It could be possible that in the depths of Titan's hydrocarbon lakes, there could be hidden pockets of water, perhaps with all the ingredients for life. Underneath the frozen surface of this Saturn moon, there could be life unlike anything we know. There's more. Mars, too, might have subsurface water. Scientists think that the red planet had a much warmer climate in the past, and that its surface was once covered in flowing water. But where is all that water now? Well, it might have frozen under the surface. Researchers believe that Mars could have a massive subterranean sea of liquid water beneath its frozen North Pole. If there's water, there could be life.